CARESOR is a European Horizon 2020 project which has the main aim of improving the safety and the efficiency of urban search and rescue operations. It is designed around an earthquake scenario, which will result in trapping of victims under the rubble, and tries to address missed capabilities of first responders in such missions. So it includes various technologies, more mature and more innovative ones, like drones, wireless geophones, ground-penetrating radars, and also our small robotic devices, the SMURFs, that are the main focus of our test today.
En tant que maire et non scientifique, je suis stupéfait et impressionné de voir le travail qui est réalisé à distance, au Japon, en Angleterre, en Norvège, en Italie, en France, en Allemagne, pour mettre en commun des connaissances et faire progresser, inventer déjà, et donc trouver une solution pour un avenir proche, pour aider les secouristes dans la recherche de personnes et donc sauver des vies.
This is the SMURF. It's one of the developments we have having in a CARESOR project. The SMURF is a small robot that is meant to help first responder to search for victims. What you see here, it's an open body with several components in it. So let's start from outside. We have some LED lights because the SMURF is operating also in dark environments. We have video cameras that's used for inspection and looking around, infrared camera, speaker, microphone, and then we have this other extra camera here used for navigation.
The SNIFFER module is a collaboration between University of Manchester and CA in France, and it contains a number of different types of sensors capable of detecting volatile molecules. And the aim is to distinguish between diseased and live victims who may be trapped under rubble or in other situations.
We have two types of sensors. Some are commercial sensors that we can buy off the shelf. And in this family of sensors, we have environmental sensors that are recording, for example, temperature and humidity in the area. And also a CO2 sensor, which is meant to detect human breathing. So when we have a victim that is alive, is breathing out CO2, and this is a very good indicator that the victim is present and alive. And then we have a second set of sensors that are specifically designed for this project, and they are relying on proteins that are coming from the nature, from animals, and that have been engineered specifically for this project at the University of Manchester.
In this device that you see here, which are able then to detect specifically the odors associated with either deceased or live persons.
So in this experiment now we are going to try to detect a victim that is hiding in these concrete pipes. So the victim is alive, it's breathing and it's releasing CO2. But this pipe is in an open environment, and depending on the wind and the drafts around these pipes, the CO2 can be released in different directions. So to make sure we pick up these signals from the SMURFs, we are going to use 4 SMURFs, 2 on each side of the pipes, and these SMURFs are going to get closer to the pipe and tell us whether we are able to detect this CO2 and to see what is the dependency on the wind for measuring this CO2 signal. Now hiding in one compartment, and the SNIFFERs are going through different compartments as like performing a blind test where they are trying to find in which section of the cellar the victim is. We are going to assess their capability to detect the presence of CO2 that we are releasing in the air from our breath.
We're building up carbon dioxide in a small confined space so that the sniffer, when it passes by, can detect a change in the atmosphere.
Avancé qui est financé en fait.
Yeah. Hello, friend number 2.
In Kershaw, we're developing a local positioning system in order to be able to locate the robot within the rubble. The system consists of two parts: the localization anchors, which are next beside me, and the localization tag that is placed inside the SMURF. Our system is innovative because it tries to find the robot within the rubble, and this is challenging due to the increased attenuation induced by the materials and the error in the range measurements. Today here in Chambéry, we are testing our system for the second time, and the results are really promising.